Hi everyone, welcome to Tech Hub. In this series, we'll talk everything about data structure. We will start by defining their abstract view and moving on with their implementation. Before starting this series on data structures, I suggest that you learn C++ and have a good understanding of all the OOPS concepts. So let's get started. What are data structures? Data structures are structures that provide a specific way of storing and organizing data. They are basically abstract data types that help in storing data. Arrays, stacks, queues are all examples of data structures. Each provide a specific way of storing data. Arrays provide a random access of data, meaning data at any index can be accessed. The stacks have a single open end, where insertion and removal is performed. So the last added element will be removed first. This is known as the LIFO principle. Unlike stacks, queues have two open ends, where insertion is performed at the rear end and deletion is performed in the front end. So the element at the front will be accessed and new data will be added at the rear end. Before we dive deeper into data structures, we need to understand what are abstract data types. Abstract data type specifies what a class does without talking about the implementation or how the data is stored in memory. Think of it like using a television. When you press the remote button to change a channel or adjust the volume, you don't need to know how the circuits inside work. You just use the interface. Similarly, an ADT defines what operations can be performed, like pushing or popping in a stack or inserting in an array, without revealing how these operations are implemented internally. For example, take this circle class. Here, the type circle can be considered abstract data type, because the user using the circle class will not know how these functions set radius or get area is implemented. He just uses the interface. Based on how they store data, data structures are classified as linear data structures and non-linear data structures. In linear data structures, data elements are arranged sequentially, that is, one after the other. Whereas in non-linear data structures, data elements need not be arranged sequentially. For example, in trees, data is arranged in the form of a hierarchy. Then linear data structures are further classified as static data structure and dynamic data structure. In static data structures, we specify the size of the data structure during declaration, which cannot be changed during runtime, and it has a fixed memory. And in dynamic data structure, we do not specify the size of the data structure during declaration. It can grow or shrink during runtime. I have given some difference between static data structure and dynamic data structure. In this series, we will cover each data structure in detail. I've also added the link to my GitHub repository in the description below. You can find all the code example and codes there. So stay tuned and let's dive deeper into data structures together.